Example number 3. An apple orchard has 20 trees per acre. The average yield is 300 apples per tree, and it is estimated that for every additional tree per acre, so the more crowded you get, the yield per tree is reduced by 10 apples. So don't draw this. I'm just going to say, okay, so you have this field and you have 20 trees on it. I can actually draw out 20. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, so this is 20 trees here. If we add an extra tree, each tree, the yield goes down just a little bit because of overcrowding. So how many trees per acre will yield the largest amount of apples? Because it's that sweet spot, right? If you add another tree, so say you have 20 trees times 300 apples, that's going to be 6,000 apples. But if you have 21 trees times 290, and 290 because it is estimated that for each additional tree, the average yield per tree is reduced by 10 apples. That's why the 290. Even though the average yield goes down, we're still getting 90 extra apples out of it. Okay, so what we want to do is find that sweet spot between overcrowding and maximum yield. So what I like to do in this kind of situation is create a chart. This helps us to define our variables. So what we want to say here is the yield equals trees per acre and times it by number of apples per tree. Now that is exactly what we did in that little in the little scrap work that I did in the beginning part here. So your total yield is trees per acre times the number of apples per tree. So this one right here would be trees per acre. And then this one right here would be apples per tree. Now, I don't want you guys to think of this in terms of independent and dependent variables right now. I just want us to find out what the pattern is. So if there are 20 trees per acre, that means that the yield per tree is 300. If we go one more tree, 21 acres, 21 trees per acre, that means that the apples per tree falls to 290. For 22, we get 280. For 23, we get 270. For 24, we get 260. And you see what's happening here, right? 25, we get 250. So as the acres get more crowded, then the apples per tree gets less. So that means what I'm going to say is let x equal the number of extra trees per acre. So that means that if we start at 20 plus x, the number of extra trees. So 20 plus 5 would be 25. But that means that when we were to create an expression here, we would say 300 minus 10 apples per one increase of trees per acre. So then, because every single time it goes down 10. So if I wanted to say, we'll let y equal the yield, which is number of apples. Actually, I'm going to be more specific in total. I'm going to say y equals 20 plus x times 300 minus 10x. So I have set up my variables. I have set up my equation. Now step number 3 is completing the square, and what we need to first do is expand. So y equals, and I'll just do this in maybe 2 different colors. 20 times 300 times 20, plus 20 times negative 10. I'll do this in this color. 20 times 300 is 6,000. Minus 200x. X times 300, x times negative 10x. So then that is x times 300 is plus 300x minus 10x squared. And now I'm just going to turn back to my black pen and collect like terms. So 6,000. Oh, actually, sorry folks, this should actually be 200. 6,000 negative 200x plus 300 is going to be plus 100x minus 10x squared. And all I'm going to do right now is change the order, okay? Because I find completing the square that way easier. So negative 10x squared plus 100x plus 6,000. Just making sure all my signs are right here. Yep. So I'm just going to factor out the common factor between for the first 2 terms here. So then y equals negative 10. So then we get negative 10x squared divided by negative 10 is simply x squared. 100x divided by negative 10 is going to be minus 10. And what I want to do, minus 10x, and then I'm going to plus something, and I'm going to minus something to make this a perfect square trinomial, plus 6,000. Now the thing that we're going to, I'm just going to go side work, rough. It's going to be b over 2 squared. Our b is negative 10 over 2 squared, which is negative 5 squared, which is 25. So remember this. So plus 25 minus 25. Y equals, and I'm gonna take this extra step, negative 10 x squared minus 10x plus 25 for our perfect square trinomial. And then we have to go negative 10 times negative 25, which is going to be positive 250 plus 6,000. So y equals negative 10. And then to factor this, x minus 5 squared plus 6250. So we're done. So now the vertex is 5, 6250. And let's interpret this. This is going to be the maximum yield. And this, the 5, is how many extra trees are on each acre. So I would say the maximum yield is 6,250 apples with maximum with 25 trees per acre. How did I get 25? Well, I go back here and say 20 plus x, since x is 5, 25. So that means it happens at 25 here. So we know that 25 25 trees per acre creates apple trees with 250 apples each. Let's just double check the math here. 25 times 250. Ah, yes. It is. Sorry, it's not in dollars, it's in apples. It is 6250. So this is just a little rough work on the side, so you don't need to write this down. This is just double checking to see if I got it right. The last thing I'd want to do is just go into the question, because there are lots of words, and so questions or bits of the question can be lost. How many trees per acre will yield the largest amount of apples? In all honesty, folks, the only thing that I needed to write down was this. Okay, the maximum yield is produced by 25 trees per acre, because it didn't ask me what the actual maximum yield is, nor did it ask me for the equation. So in this one, I could have used this factored form here, found out what, when I set y equal to 0, find out what my x-intercepts are, figure out what my figure out what my x-coordinate of my vertex is, and plug that back into the original equation. However, this completing of the squares wasn't actually all that bad, and it comes out with a really nice little equation right at the end. And you can kind of feel good, because you literally created this this equation from the knowledge and from the information that you gathered from the question. So good for you.